at his man Taylor. Slam dunk!
Oh boy, Nolan's.
Watching an athlete in motion, it's clear what a finely tuned machine the body is. Muscles automatically exert just the right amount of energy and strength for the task at hand. And we do it without conscious thought.
You don't think about, I'm going to have my heart beat. You don't think about breathing, but your lungs breathe. You don't think about walking even. That's the kind of thing we're working on.
With support from the National Science Foundation, Brandeis University physicist Seth Fraden directs the Bioinspired Soft Materials Center. Here they want to understand the fundamentals of how living things move, then apply that knowledge to create a new class of materials with similar properties. The fuel to power them would be built right in.
Can you make objects that consume energy and produce motion that can sense the environment and then move in a directed way? Yes. We're talking about blurring the boundaries between the animate and the inanimate.
So can you just explain to us what are we seeing on the left and what are we seeing on the right?
Zvonimir Dojic studies motor proteins inside cells. To test his understanding, he's built artificial cilia.
What is surprising is that you can only take a few of these building blocks, Legos of life, and put them together. It looks like a living organism, but it is in fact just a material that has 3 or 4 components. And so that's something that we definitely didn't expect, but it was a really thrilling discovery.
He's also working on a group of artificial cilia that beat together in sync, similar to the collective movements of a school of fish. Such cooperative action could lead to the development of more sophisticated materials to carry out more complicated tasks, like pipes that pump themselves.
Your heart will pump fluids, your intestine will pump fluids. Now if we want to pump oil through a pipe, we have to have a pump at one end and create pressure to drive it. Why can't we have tubing that consumes energy that flows through it and then contract?
Fraden is optimistic that understanding these basics will speed the development of what's called active matter, which mimics living systems.
We don't see any reason why the animate should be confined to the living. Animation means motion, it doesn't mean living.
Even though developing practical products is likely years away, the potential applications are endless.
How about if you could go and buy a muscle suit that actually had musculature in it and would give you strength? We're anticipating creating materials that will have attributes that we are very familiar with in living organisms.
Making materials that power themselves to flex and bend or shimmy and shake. Now that's having all the right moves. For Science Nation, I'm Miles O'Brien.